Hello, everyone. Welcome to today's episode of the Math Script. This is Tony, the tutor from AIM, Affluence in Mathematics. And today we will be solving a two-step algebra word problem. This is 8th grade mathematics. May pour over into 9th grade if your students take 9th grade algebra. So the problem reads, this year, your brother Jack will be 2 years from being twice as old as your sister Jen. The sum of Jack's age and 3 times Jen's age is 66. How old is Jen? So of course now we're solving for the age of Jen. So the first thing I want to do is I want to identify what I'm solving for. So I'm solving for the age of Jen. Now, I have 2 variables here in this problem. I have the age of Jack, and I have the age of Jen. We're going to call Jen N, and we're going to call Jack K. Now we're going to say, what are some context clues and words that we can translate into math? So let's start by solving for the age of Jack, because the first sentence gives us Jack's age. So let's break down our math language here. We say that this year, your brother Jack will be. So we say the term will be implies not only that we're solving for Jack, but that Jack will be equal to the equation. So we say Jack will be 2 years from being twice as old as your sister Jen. So Jen is N. We've already identified that. So Jack will be, so Jack K will be twice as old, will be 2 years from being twice as old as your sister Jen. So it's implied from twice as old implies that we will be doing a multiplication of your variable times 2 for twice as old. So as we proceed, we begin to say, okay, so you have your 2n, but we're not done, because Jack will be equal 2 years from being this age. So now our next terminology we would say is from being. 2 years from being twice as old as your sister Jen. So from being implies subtraction. And the 2 years implies subtraction because he is not that old yet. He has yet to reach the age of being twice Jen's age. So now we're looking for our second equation. So our second equation, well, first of all, before we move on to our second equation, however many variables you have in an equation, in order to solve for both variables, you need that number of equations. So here we've identified we have two variables, but we only have one equation. So now we need a second equation to solve for what the question asks, which is the age of Jen. So the second equation that they give us is that the sum of, so already I know that I'm doing an addition problem. The sum of Jack's age, so we have Jack's age, the K, and 3 times Jen's age is 66. So we go here, we say Jack's age 3 times Jen's age is 66. Is another common math term implying equal to. So you know that the sum of their ages, so you have a plus Jack's age, which is K. You have an equal sign, which is 66, based on your problem. 3 times Jen's age. So 3 times, you guys can probably guess what that is, which is multiplication by 3. So 3 times Jen's age. Well, you may be asking yourself, how do I solve this problem? I have 2 equations and I have no idea how to solve them because neither of them give me straight up numbers and I have variables. Well, here, this is commonly recognized as a substitution problem. Where you have K is already solved for and can be placed into the equation to solve for Jen's age. So you would rewrite equation 2 as 66 is equal to 3n. Now you do your substitution for K. K is equal to 2n, the quantity of 2n minus 2. So from here, I would do some grouping. So I would group my like terms. So I would say 66 equals, I break my bracket here and group my 2 like terms with common variables. 3n plus 2n minus 2. And from here, I would add 2 to both sides. Plus 2. So by adding 2 to both sides and grouping my common term, I have 5 n, this is now 0, is equal to 68. Of course, now you do division, divide by 5, my inverse operation here. Jen is about, what do we say, 1, drop the 1 down, 5, 3, 13 and a half. 13.6. So if you wanted to convert this number 13.6 into years and months, of course, the whole number 13 is how many years she is, years old. Your 0.6, 0.6, which represents 60% because it's a percentage of a whole. This is 60% of a whole, times 12 months. Give you 7.5 or 7.2 months. Then of course your 0.2 conversion to finally convert the days would be 0.2 times a standard 28-day, 4-week, 28-day month. So times 28 is 5.6 days. We're not going to break it down any further than that. So Jen is 13 years old, 7 months, and because you can't have an incomplete day, we're going to round the day up and we're going to say 6 days. So this is Jen's precise age based on the information given. The key things we want to, I know this looks like a lot right now, but if you follow the matriculation of the video, you should be able to understand it. If you guys have any problems, please feel free to comment as to whether or not this problem confused you or I did not convey the problem properly to your understanding. This is AIM. This is the math script. We do appreciate you taking the time to work with us and taking the time to enjoy some free content and a free problem and get to know the language of mathematics. So this is Tony with AIM signing out, saying thank you for joining me today.